हे देयर, हे एवरीवन, वेलकम टू माय चैनल। तो आज के पॉडकास्ट में हम बात करेंगे विटामिन के फंक्शंस के बारे में। एंड हम कर रहे हैं प्रीवियस ईयर क्वेश्चन पेपर, जो हम 2018 जुलाई का क्वेश्चन पेपर कर रहे हैं। सो यहाँ पे हम बात कर रहे हैं विटामिन के का बायोकेमिकल फंक्शंस। सो लेट्स सी। सो फर्स्ट, विटामिन के क्या है? एक फैट सॉल्युबल विटामिन है। सो विटामिन के इज़ अ फैट सॉल्युबल विटामिन. Vitamin K is a fat soluble vitamin with a specific coenzyme function. It is required for the production of blood clotting factor essential for coagulation. In German, coagulation, hence name K for vitamin. जर्मनी में जो K होता है, कोएगुलेशन होता है, वो के से स्टार्ट होता है, सी से नहीं। तो इसलिए कोएगुलेशन जो के से स्टार्ट हो रहा है, इसलिए विटामिन के बोल रहे हैं। तो विटामिन के इज़ रिक्वायर्ड फॉर द प्रोडक्शन ऑफ क्लॉटिंग फैक्टर्स। तो अब हम बात करते हैं इसका फंक्शन, बायोकेमिकल फंक्शंस ऑफ विटामिन के। सो द फंक्शंस ऑफ विटामिन के आर कंसर्न विद ब्लड क्लॉटिंग प्रोसेस. इट ब्रिंग्स about the post translation modification of certain blood clotting factors. The clotting factor 2, prothrombin 7, 9 and 10, 2, 7, 9, 10 are synthesized as inactive precursors, zymogens in the liver. Vitamin K act as a coenzyme for the carboxylation of glutamic acid residues present in the protein, and this reaction is catalyzed by a carboxylase microsomal carboxylase enzyme. Okay, so जो function है विटामिन के आर कंसर्न विद ब्लड क्लॉटिंग प्रोसेस. विटामिन के आर कंसर्न विद ब्लड क्लॉटिंग process. So vitamin K are concerned with blood clotting process. Vitamin K are concerned with the functions of vitamin K are concerned with blood clotting process. It brings about the post-translational modifications of certain blood clotting factors. So it brings about the post-translational modification of certain blood clotting factors. The clotting factor 2 क्या है? Prothrombin 7, 9 and 10 are synthesized as inactive precursors, zymogens in the liver. Vitamin K act as a coenzyme for carboxylation of glutamic acid residues present in the protein, and this reaction is catalyzed by a carboxylase enzyme. So vitamin K का function क्या है? The functions of vitamin K are concerned with blood clotting process. The functions of vitamin K are concerned with blood clotting factors. Blood clotting process. The functions of vitamin K are concerned with blood clotting process. It brings about the post-translational modifications of the certain blood clotting factors. It brings about the post-translational modifications of certain blood clotting factors. The clotting factor 2, prothrombin 7, 9 and 10 are synthesized as inactive precursors, zymogens in the liver. Zymogens in the liver. Vitamin K acts as a coenzyme for the carboxylation of glutamic acid residues present in the proteins, and this reaction is catalyzed by a carbohydrate microsomal enzyme. It involves the conversion of glutamate to gamma carboxyglutamate and requires vitamin K, oxygen and carbon dioxide. So the functions of vitamin K are concerned with blood clotting process. The functions of vitamin K are concerned with blood clotting process. Functions of vitamin K are concerned with blood clotting process. It brings about the post-translation modifications of blood clotting factors. The clotting factor 2, prothrombin 7, 9 and 10 are synthesized as inactive precursors, zymogens and the liver. Vitamin K act as a coenzyme for the carboxylation of glutamic acid residues present in the proteins, and this reaction is catalyzed by carboxylase. So let's अभी तो हमें पता चल गया कि vitamin K are responsible for the post-translational modifications of certain blood clotting factors, that is 2, 7, 9, 10 blood clotting factors. They are synthesized as inactive zymogens precursors in the liver. So vitamin K activates them. It causes the post-translational modifications of these 2, 7, 9, 10 clotting factors. So now your password of your phones, of anything, should be 2, 7, 9, 10. 2, 7, 9, 10. Okay, these are the clotting factors, 2, 7, 9, 10. Talking about the vitamin K act as a coenzyme for कार्बोक्सिलेशन ऑफ ग्लूटामिक एसिड. सो जैसे कि हमने देखा था कि जो विटामिन सी है वो हाइड्रोक्सिलेशन के लिए रिस्पॉन्सिबल होता है, वैसे विटामिन के इज़ रिस्पॉन्सिबल फॉर कार्बोक्सिलेशन ऑफ ग्लूटामिक एसिड. कार्बोक्सिलेशन ऑफ ग्लूटामिक एसिड रेसिड्यूज प्रेजेंट इन द प्रोटीन्स में जो ग्लूटामिक एसिड के रेसिड्यूज है उसका कार्बोक्सिलेशन कराता है बाय द एंजाइम कार्बोक्सिलेज. ओके, इट इन्वॉल्व्स द कन्वर्शन ऑफ ग्लूटामेट to gamma carboxyglutamate and requires vitamin K, oxygen and carbon dioxide. Carboxylation requires carbon dioxide, oxygen and vitamin K. The formation of gamma carboxyglutamate is inhibited by dicumarol, an anticoagulant found in spoiled sweet clover. Warfarin is a synthetic analog that can inhibit vitamin K action. तो antagonist of vitamin K. That vitamin K is inhibited by warfarin. Warfarin is a synthetic analog that inhibit vitamin K action. So vitamin K is also required for carboxylation of glutamic acid residues of osteocalcin and the matrix GLA protein in bone and nephrocalcin in kidney. The mechanism of carboxylation is not fully understood. It is known that a 2,3 epoxide derivative of vitamin K is formed as an intermediate during the course of the reaction. Dicuminol inhibits the enzyme reductase that converts epoxide to active vitamin K. Role of GLA in clotting. GLA is nothing but gamma carboxyglutamate. So the gamma carboxyglutamic acid residues of clotting factor are negatively charged and they combine with positively charged calcium ions to form a complex. The mechanism of action has been studied for prothrombin. The prothrombin calcium complex binds to the phospholipids on the membrane surface of the platelets. This leads to the increased conversion of prothrombin to thrombin. So talking about vitamin K, so vitamin K are responsible for post-translational modifications of some clotting factors 2, 7, 9, 10. Okay, 2 is prothrombin, we know. So vitamin K act as a coenzyme for the carboxylation of glutamic acid residues present in the protein, and this reaction is catalyzed by a carboxylase microsomal enzyme. So it involves the conversion of glutamate to gamma carboxyglutamate, glutamate to gamma carboxyglutamate, and vitamin K is responsible for conversion of glutamate to gamma carboxyglutamate, and this carboxylation requires vitamin K, oxygen and carbon dioxide. The formation of gamma carboxyglutamate is inhibited by sweet clover, spoiled sweet clover, the formation of gamma carboxyglutamate is inhibited by dicuminol. Dicuminol is an anticoagulant and it is found in spoiled sweet clover. It is found in sweet clover. Dicuminol. So warfarin is a synthetic analog that can inhibit vitamin K. Vitamin K is also required for carboxylation reactions, carboxylation of glutamic acid residues of osteocalcin and the matrix GLA protein in bone and neocalcin in kidney. The mechanism of carboxylation is not fully understood. It is known that a 2,3 epoxide derivative of vitamin K is formed as an intermediate during the course of the reaction. Dicuminol inhibits the enzyme reductase that convert epoxide to active vitamin K. So as we study that carboxylation of glutamate to gamma carboxyglutamate is inhibited by the dicuminol, which is found in the spoiled sweet clover. So what happens is the mechanism of carboxylation is not fully understood. It is known that a 2,3 epoxide derivative of vitamin K derivative 2,3 epoxide is formed as an intermediate during the course of the reaction. 2,3 epoxide intermediate is formed, and this dicuminol inhibits the enzyme reductase that converts epoxide to active vitamin K. So dicuminol inhibits this conversion of epoxide to active vitamin K. This conversion is inhibited because dicuminol inhibits the enzyme reductase. What is the role of GLA in clotting? The gamma carboxyglutamic acid residues of clotting factor are negatively charged and they combine with positively charged calcium to form a complex. The mechanism of action has been studied for prothrombin. So the prothrombin calcium complex binds to the phospholipids on the membrane surface of the platelets. So this leads to the increased conversion of prothrombin to thrombin. So let's talk about carboxylation reaction of vitamin K. So what happens here, there is a protein, that is glutamate protein, and the protein is there. Glutamate residues present in the protein is there. So this glutamate is converted into gamma carboxyglutamate, that is gamma carboxyglutamic acid, it by the enzyme carboxylase. So how vitamin K acts as a coenzyme for this? So what vitamin K does is, so this vitamin K in this reaction, when the glutamate is converted to gamma carboxyglutamic acid, at the time vitamin K, that is also known as hydroquinone form. Vitamin K का जो hydroquinone form है, it will convert into 2,3 epoxide form, and this 2,3 epoxide form convert into quinone. So this quinone by the enzyme reductase. It will convert into quinone form, and then quinone form again by the enzyme reductase convert into vitamin K, that is hydroquinone. Hydroquinone is the active form of vitamin K, so it will convert into hydroquinone. So what is happening is 2,3 epoxide form is there. 2,3 epoxide is the inactive form. 2,3 epoxide by the help of the reductase it convert into quinone form. Quinone converts into hydroquinone, which is the active form of the vitamin K. So like this, what happens? The decumerol and warfarin, what they do, they inhibit the enzyme reductase, so that 2,3 epoxide is not converted into quinone, and hence it is not converted into vitamin K hydroquinone. Hence carboxylase enzyme is not activated. Okay, so like this it happens. Now talking about vitamin K dependent carboxylation of the precursors of the clotting factor. So vitamin K dependent carboxylation of the precursors of clotting factor. So the protein is there, no? The protein precursor of clotting factor 2, 7, 9, 10. So these are synthesized in the liver. These are synthesized in the liver as the precursors, zymogens. So in that glutamate is there. That glutamate should convert into gamma carboxyglutamic acid. So this can be done by vitamin K. Vitamin K it will activate the enzyme carboxylase and oxygen and carbon dioxide. Vitamin K carboxylation reaction takes place. Glutamate is converted to gamma glutamic acid, gamma carboxyglutamic acid, and that the clotting factors become active. You know? So but this is not occurring. Why this is not occurring? Why this is not occurring? Because of decumerol and warfarin, which are the inhibitors of vitamin K. They inhibit the enzyme reductase. What reductase does is 2,3 epoxide is there na, of 2,3 epoxide form of vitamin K. It will convert into quinone form by the reductase, and then quinone form will convert to hydroquinone. That is the active form of the vitamin K. So this conversion occurs by reductase. This reductase is inhibited by decumerol and warfarin. Okay, what is the role of gamma carboxyglutamic acid in clotting? So this gamma glutamic acid is a negatively charged. This is present in the clotting factors. The gamma carboxyglutamic acid residues of clotting factors, they are negatively charged, and they combine with the positively charged calcium to form the complex. The mechanism of this is studied for prothrombin. So the prothrombin calcium complex binds to the phospholipid on the membrane membrane surface of the platelets. So this leads to the increased conversion of prothrombin to thrombin. So the clotting factors are synthesized in the inactive form in the liver. These are activated by vitamin K. Vitamin K, what does it do? What vitamin K does? Vitamin K, what it does? So vitamin K, it converts the glutamate to gamma carboxyglutamic acid. This gamma carboxyglutamic acid, how it plays important role in clotting. These are present as residues in the clotting factors, and these are negatively charged, so they bind with the positively charged calcium. So this mechanism is studied in the for prothrombin. So what happens is prothrombin calcium complex is formed. This prothrombin calcium complex binds to the phospholipid of the platelets on the membrane surface of the platelets. So this leads to the increased conversion of prothrombin to thrombin. So from where you can get the vitamin K? So you can get the vitamin K from the cabbage, cauliflower, tomatoes, alfalfa, and spinach. The green vegetables, good sources, and you can get from the egg yolk, meat, liver, cheese, dairy products. It is also present in egg yolk. It is also present in egg yolk, meat, liver, cheese, and dairy products. So strictly speaking, there is no RDA for vitamin K, since it can be adequately synthesized in the gut. So it is however recommended that half of the body requirement is provided in the diet, while the other half is met from the bacterial synthesis. So according the suggested RDA for an adult is only 70 to 100 microgram per day. Vitamin K. So how prothrombin converts into prothrombin? So what happens here? The gamma carboxyglutamate complexed with the calcium prothrombin platelet membrane with phospholipids. So it will bind with the platelet membrane of phospholipid with the help of calcium. This is the mechanism of action of gamma carboxyglutamate of prothrombin in blood clotting. So vitamin K is all about the clotting and conversion of glutamate to gamma carboxyglutamic acid and this occurs by the enzyme carboxylase, which requires vitamin K. Vitamin K 2,3 epoxide, which is the inactive form, is converted into quinone form by reductase. This reductase again acts on the quinone and convert into hydroxyquinone. The reductase can be inhibited by decumerol and warfarin. Okay, so this you need to remember. The antagonist of vitamin K is heparin, bis hydroxycoumarin, act as anticoagulants and are antagonists to vitamin K. So naturally found in our body is the heparin. Heparin is an anticoagulant, and bis hydroxycoumarin act as antagonist and are antagonist to vitamin K. They are anticoagulants. The salicylates and decumerol are also antagonists to vitamin K. Decumerol is structurally related to vitamin K and act as competitive inhibitor in the synthesis of active prothrombin. It acts as competitive inhibitor. It acts as competitive inhibitor in the synthesis of active prothrombin. Deficiency, what happens? The deficiency of vitamin K is uncommon since it is present in the diet in sufficient quantity and are adequately synthesized by the intestinal bacteria. However, vitamin K deficiency may occur due to its faulty absorption, lack of bile salts, loss of vitamin into feces, diarrheal diseases, and administration of antibiotics, killing of intestinal flora. Deficiency of vitamin K leads to lack of active prothrombin. Deficiency of vitamin K leads to lack of active prothrombin in the circulation. So this result is the blood coagulation is adversely affected. The individual bleeds profusely even for minor injuries. The blood clotting time is increased. What is hypervitaminosis K? Administration of large vitamin K produces hemolytic anemia and jaundice, particularly in infants. Toxic effect is due to increased breakdown of RBC. Recommended dietary is 70 to 100 micrograms per day. However, it is sufficiently present and adequately synthesized in the gut by the intestinal bacteria. Intake of high doses of antibiotics can kill this intestinal bacteria, intestinal flora, and cause vitamin K deficiency. However, it is very uncommon, and for minor injuries, it bleeds profusely and the blood clotting time is increased in case of deficiency. So absorption and transport, vitamin K is taken in the diet or synthesized by the intestinal bacteria. Vitamin K is taken in the diet or synthesized by the intestinal bacteria. Its absorption takes place along with fat and is dependent on bile salts. So its absorption takes place along with fat, that's why it depends on the bile salts. If there is lack of bile salts, then vitamin K absorption is not proper. Vitamin K is transported along with LDL and is stored mainly in the liver. So its transportation is along with the LDL, low density lipoprotein. Talking about the chemistry, so we know vitamin K is a fat soluble vitamin, and with a specific coenzyme function, it is required for production of blood clotting factors essential for coagulation. Chemistry, vitamin K exists in different forms. Vitamin K1 is phyllocyanone. It is present in plants. Vitamin K2, menaquinone, is produced by the intestinal bacteria and found in animals. Vitamin K3, menadione, is a synthetic form. So menadione is a synthetic form, vitamin K3. All the three vitamins are between K1, K2, K3, that is phyllocyanone, menaquinone, and menadione, are naphthoquinone derivatives. Isoprenoid side chain is present in vitamin K1 and K2. The three vitamins are stable to heat. Their activity is, however, lost by oxidizing agents, irradiation, strong acids, and alkalis. Strong acids, alkalis, oxidizing agents, irradiation, but they are stable to heat. All the three vitamins are stable to heat, but their activity is lost by oxidizing agents, irradiations, strong acids, and alkalis. So all the three vitamins K1, K2, K3, naphthoquinone derivatives. Isoprenoid side chain is present in vitamin K1 and K2. So in vitamin K1 and K2 you can see isoprenoid side chains. But in K3 there is no isoprenoid side chain. But all the three vitamins K1, K2, K3, phyllocyanone, menaquinone, and menadione, these are stable to the heat. and the activity is however lost by oxidizing agents, irradiation, strong acids and alkalis. Their activity can be lost. So there are three types of vitamin found, that is vitamin K1, phyllocyanine, vitamin K2, that is minoquinine, and vitamin K3, that is minadione. So vitamin K1 and K2, they contain a group, that is isoprenoid side chain. Isoprenoid side chain are present in vitamin K1 and K2. Isoprenoid side chain is present, whereas in vitamin K3 there is no isoprenoid side chain. So what you need to remember about vitamin, first you have to write the introduction. It is a fat soluble vitamin. Vitamin K is a fat soluble vitamin, and this vitamin functions as the coenzyme, and it is required for the for production of clotting factors, blood clotting factors, and it is derived from the German word coagulation, K for coagulation, and hence the name vitamin K. So what you need to remember here in the introduction point, you need to write 3 points. First is vitamin K is the fat soluble vitamin. We know all are fat soluble except vitamin B and C. Okay, B complexes and C are water soluble. So vitamin K is a fat soluble vitamin. It functions as a coenzyme. The second point you need to write is it is required for the production of blood clotting factors. Blood clotting factors. It is essential for coagulation. So 2 points you need to remember. You have to write, first one is vitamin K is the fat soluble vitamin. It functions as coenzymes with a specific coenzyme function as coenzyme. Another thing you have to write is it is required for the production of blood clotting factors, which is essential for coagulation of blood. Okay, chemistry. In chemistry, you have to write there are 3 types of vitamin. Vitamin K1, that is phyllocyanine, derived from plants, present in the plants, and vitamin K2, minoquinine, which is present in which is synthesized by the intestinal bacteria and found in animals. Vitamin K3, minadione, which is a synthetic form. Vitamin K1, K2, K3, they are derivatives of naphthoquinone. And vitamin K1 and K2, they contain isoprenoid side chains. All the 3 vitamins are stable to heat, but but their function can be lost by oxidizing agents, irradiation, strong acids and alkalis. Okay, minadione is the synthetic. Vitamin K3 is synthetic. Absorption and transport. Vitamin K is taken in the diet, or it is synthesized by the intestinal bacteria. Its absorption takes place along with the lipids, along with the fat, and is dependent on bile salts. It is transported along with LDL and is stored in the liver. It is stored in the liver and it is transported along with the LDL. What are the biochemical function? The function of vitamin K are concerned with blood clotting factors. It brings about the post-translational modifications of the blood clotting factors, that is clotting factor. What are the 2? Prothrombin, 2, 7, 9, 10. 2, 7, 9, 10, and these are the clotting factors. These clotting factors are synthesized as precursors, zymogens in the liver, and these are activated by the vitamin K. Vitamin K functions as coenzyme for the carboxylation of glutamate to gamma carboxyglutamic acid. Okay, this you have to write. So glutamate is present as a residues in the protein of clotting factors, and the glutamate is activated by the glutamate is converted into gamma carboxyglutamate by the enzyme carboxylase, for which vitamin K, carbon dioxide and oxygen is required. Okay, warfarin and decumerol, they are the anticoagulants, they are the antagonists, they inhibit the vitamin K. Vitamin K 2,3 epoxide is the inactive form. It converted into quinone form by reductase and quinone form to hydroquinone by reductase. The reductase is inhibited by warfarin and decumerol. Decumerol is extracted from the sweet clover, spoiled sweet clover. Okay, and what is the role of gamma glutamic acid, gamma carboxyglutamic acid? The gamma carboxyglutamic acid is residues of clotting factor. These are negatively charged and hence they attract positively charged calcium ions. This mechanism is studied in the clotting factor 2 prothrombin. Prothrombin calcium complex is formed, which binds to the phospholipid on the surface of the platelets, on the membrane surface of the platelets. This leads to increased production of prothrombin, conversion of prothrombin to thrombin. Okay, recommended. It is adequately synthesized in the intestine by the intestinal flora, and it is also present in good quantities in the diet. But Accordingly, the suggested RDA for an adult should be 70 to 100 micrograms per day. 100 micrograms per day, you can take 70 to 100 micrograms per day. What is the dietary source? Cabbage, cauliflower, you can take cabbage, cauliflower, tomatoes, spinach, alfalfa, green vegetables, good sources, and also present in egg yolk, meat, liver, cheese, and dairy products. Also it is found egg yolk, meat, liver, cheese, dairy products. But green vegetables, tomatoes, alfalfa, and spinach are good sources. Deficiency symptoms. Deficiency of vitamin K is uncommon, but if because of the lack of bile salts, faulty absorption like diarrhea, and administration of the antibiotics killing a lot of intestinal bacteria, intestinal flora causes the deficiency of vitamin K, and this leads to the profuse bleeding to small cuts for minor injuries also, and the blood clotting time is increased. Hypervitaminosis of K, vitamin K, hypervitaminosis K, and that administration of large doses of vitamin K, it causes the jaundice and hemolytic anemia and jaundice. It is particularly common in infants. So it causes increased breakdown of RBC. The toxic effects of the hypervitaminosis K causes increased breakdown of RBC, leading to jaundice and hemolytic anemia. Antagonist of vitamin K is heparin and bis-hydroxycuminin, which act as an anticoagulant, and antagonist to vitamin K. The salicylates and decumeral antagonist to vitamin K. Salicylates and decumeral warfarin antagonist to vitamin K, and the decumeral particularly they act as competitive inhibitor in the synthesis of active prothrombin. For the synthesis of active prothrombin. Thank you guys. This is all about vitamin K.